In this video, I'm about to discuss problems involving conic sections. I am your teacher, Sir Paul Jorad R. Santos, part of Senior High School Department of Dasmariñas Integrated High School. For our first objective, recognize the equation and important characteristics of the different types of conic sections. Okay, that is our lesson after our after your long quiz, no? And for this video, you are or I am about to show you how to solve situational problems involving conic sections. Let us now proceed to the first example. Okay, we have here a single lane street 10 feet wide goes through a semicircular tunnel with radius 9 feet. The question is, how high is the tunnel at the edge of each lane? Round off to two decimal places. We will round off our answer into two decimal places. Now, I have here an illustration, a semicircular tunnel. Okay, its center is located at 0, 0 or at the origin. Now, since we have this single lane street 10 feet wide, okay, as you can see, I have here from point C to point E, 10 units stands for or equivalent to 10 feet. And what we want to find here is the height of or the distance or the measure of this line segment DE because that is the height of the tunnel at the edge of each lane. Okay? Meaning to say, given the value of x as 5, we want to find the value of y in D, no? Or the ordinate of D. So as I have said, let the center of the semicircle or semicircular tunnel be at 0, 0. Since the radius is 9 feet, we can say that our equation can be written as x squared plus y squared equals 81 because our center is at the origin and our radius is 9, so r squared will be 81. The task is to find the height of the tunnel at the edge of each lane, which is 5 feet away from the center. Okay, actually, we can also find the value of y here, no? But uh, perhaps you can just use this point D. We will determine the height or the y value in point D. Now, with this, we can say that we have to solve for the positive value of y if x is equal to 5. Now, we already have this equation x squared plus y squared equals 81. So, I just replace x here by 5 since the value of x is 5. So, by the addition property of equality, I subtract both sides by 5 squared. But actually, you can just simplify it first, no? It will be 25. So, simplifying 5 squared will give us 25. And 81 minus 25 is 56. Y squared is 56, but we are asked for the value of y. So, to do that, we need a calculator to uh, get or to determine the value of y. And that will be the square root of 56, which is approximately equal to 7.48. For our conclusion, thus the height of the tunnel at the edge of each lane is 7.48 feet. Okay, now let us have the second example. A satellite dish has a shape called paraboloid, where each cross-section is a parabola. Since radio signal, parallel to the axis, will bounce off the surface of the dish to the focus, the receiver should be placed at the focus. The question here is, how far should the receiver be from the vertex if the dish is 12 feet across and 4.5 feet deep at the vertex? To illustrate the given, we have here Okay, the dish is 12 feet across, meaning to say the distance between point B and point A is 12 feet. Those are the edges of the paraboloid. And from this point up to here is 4.5 feet. Up to the vertex, no? Or from the vertex up to the point here. Its vertical distance is 4.5. Now, as you can see, I let the vertex of the parabola be at 0, 0 because it is easier if we have the vertex at the origin and the uh the equation or the standard equation is more simple or simpler than having the parabola anywhere else or having the parabola having the parabola's vertex at HK. Now, since the parabola opens upward, we can say that the parabola follows the equation x squared is equal to 4ay. Okay, based on what we have discussed, if the parabola opens upward and the vertex is at 0, 0, we have this x squared is equal to 4ay. Now, what we want to find here, oh, by the way, since the satellite dish is 12 feet across, the horizontal distance from the vertex to edge of the dish is 6 feet and its height is 4.5 feet. Meaning to say, from the vertex, its distance or is its horizontal distance up to point A is 6 feet and up to point B it is also 6 feet while its height is 4.5 feet. With this, or hence we have 4.5 as a point on the parabola. Okay? Meaning point here, point A, point A here has the coordinate 6, 4.5. Now, the task is to find the distance between the focus and the directrix, which is the value of A in the equation. With this, we have x squared is equal to 4ay. Now, what is the value of x? What is the value of y? Since 4.5 is a point on the parabola, meaning it will satisfy this equation, x squared is equal to 4ay. And we can use these values for us to determine the value of a. So by substitution, we have here 6 squared because the value of x is 6 is equal to 4a times 4.5. And then, excuse, and then, let us simplify this. This will be 6 squared is 36 and 4 times 4.5 is 18. Now, we have here 36 is equal to 18a. And dividing both sides by 18 to eliminate the numerical coefficient of a, we have a is equal to 2. Okay? Now, for our conclusion, thus the receiver should be 2 feet away from the vertex. The distance between the focus and the vertex is 2 feet. Okay? That is for our second problem. Let us proceed to our third problem. A tunnel has the shape of a semi-ellipse that is 15 feet high at the center and 36 feet across at the base. At most, how high should a passing truck be if it is 12 feet wide for it to be able to fit through the tunnel? Round off your answer to 2 decimal places. So we have this figure. Actually, it is similar, almost similar to the first problem, but in this case, we are dealing with ellipse. In uh Now let me illustrate, no. we have here 15 feet high at the center from this point center to the highest point of the semi-ellipse. Okay, so its height is 15 feet and the semi-ellipse is 30 feet across at the base. From this point up to this point is 36 feet. So we have your negative 18.0 and 18.0. Now, the track, let us just say this rectangle here is a diagram or an illustration of a track. And as you can see, it is 12 feet wide. We want to find the highest possible or the maximum height of a track that can pass through this semi-ellipse. Given that, or by this, by the way, we can conclude that the center of the ellipse at, or we let the center of the ellipse at the 0, 0, 0. And based on the illustration, the ellipse is horizontal. The ellipse has an equation, or because it is horizontal, it has an equation, x squared over a squared plus y squared over b squared is equal to 1. And since the tunnel is 30 feet across at the base, okay, this is the uh, base and it is 36 feet across, no? Hence, we can say that the length of the major axis is 2a, which is 2a equals 36. Okay? So, we have here 2a as 36. And if 2a is 36, that implies that the value of a is 18, which is half the major axis. While b is 15 because that is the distance between the center up to a covertex. Okay, the covertex here is this point. Okay, so from this point, 0, 0 up to here is 15 feet. Okay, so b is equal to 15. The goal is to find the maximum height of the track that has a width of 12 feet that can pass through the tunnel. If the track will pass through in the middle, the edges of the track will be 6 feet away from the center horizontally. Like what I have presented earlier, as you can see, okay, the edge is at 6, 0, no? Or at this line x equals 6 and x equals negative 6. So, since we have here a point A and we know that the abscissa of this point is 6. We need to find the value of y because that will be the limit. Or we need to find the coordinate because that will be the limit of the height of the track that can pass through this semi-ellipse. Okay? Now, in other words, we want to find the maximum height y of a track given the value of x as 6. We have this equation, the standard equation. Okay, we obtain it from here. We know the value of x, that is 6. We know the value of a, which is 18. We know the value of b, and that is 15. So let us substitute. Okay, 6 squared over 18 squared plus y squared over 15 squared is equal to 1. And replacing 6 or simplifying 6 squared will be 36. Simplifying 18 squared, that will be 324. And simplifying 15 squared, that will be 225. And now, uh, reducing this 36 over 324 into its lowest term will give us 1 over 9. Subtracting both sides by 1 over 9, it will give us this. Okay? From here, I just, oh, maybe your teacher before told you that this process is what we call transpose. but it is just addition property of equality. Okay? I moved 1 over 9 to the right, so it became negative. So 1 minus 1 over 9, that will be 8 over 9. And then for us to eliminate the denominator of y squared, we just need to multiply both sides of the equation by 225. So 225, in other words, will be multiplied to 8, and that will be 1,800 over 9. And simplifying 1,800 over 9 will be 200. Now, y squared is 200. The value of y will be, actually, it should be 10 square root of 2 to be exact. But since we are asked to round off our answer into two decimal place, the answer will be approximately equal to 14.14. Hence, the height of the track with 12 feet width should not exceed 10 square root of 2 feet or 14.14 feet. And that is for our third problem. And for our last problem, an explosion is heard by two stations, 1,200 meter apart, located at negative 600 and 600. If the explosion was heard in f sub 1 2 seconds before it was heard in f sub 2, identify the possible locations of the explosion. Use 340 meter per second as the speed of sound. Take note that the speed of sound is not exactly 340 meter per second, but it is 343. But we will be using 340. Okay. To illustrate, I have here of f sub 1. By the way, I just rescale it, no. It is not 600, negative 600, 0. It is just negative 60 and 60 for us to uh for me to illustrate it like better. Okay? Because it is too huge if I will be using the the original graph. Now let the origin be the center of the hyperbola. Using the speed of sound, this implies that the sound travel 340 times 2, which is 680 meters more to reach f sub 2 as compared to f sub 1. So, in other words, the difference between the distance of the explosion to f sub 2 and the explosion to f sub 1 is 680 meters. If we subtract the distances between these two, it will be 680 meters. Okay? And we denote it, or that difference will be uh, equal to 2a. Okay? This only shows that the difference 2a between the distances from the explosion to the foci is 680 meters. Now, the explosion, or thus the explosion, is on the hyperbola with foci f sub 1 and f sub 2 on the part that is closer to f sub 1 because uh, the sound was heard 2 seconds in advance in f sub 1 than in f sub 2. Okay. Now, we have here C as 600 because that is the distance between the vertex or the focus up to the center. Okay? As we all know that C stands for the distance between the center and a focus. And we also have here from our previous, or what I mentioned earlier, that 2a is equal to 680. So it implies that a is 340 and a squared will be 115,600. Hence, okay, if we have this b squared is equal to c squared minus a squared, manipulating the formula of c squared, if we are given, or I just manipulate it, the original equation here is 6, or c squared is equal to a squared plus b squared, or c is equal to the square root of a squared plus b squared. But transforming it, since b is unknown, okay, we have here b squared is equal to c squared minus a squared. Now, what is our c? That is 600. What is our a? That is 340. A squared is 115,600. So in other words, we have here 600 squared minus 340 squared, or 360,000 minus 150,000, or 115,600. Subtracting these two will give us 24 or 244,400. So that will be the value of b squared. Actually, our goal here is to uh, determine the standard equation of the parabola or the hyperbola, because it represents the possible location of the explosion. Okay, thus the explosion could be anywhere on the left branch of the hyperbola. X squared over 115,600 minus y squared over 244,400 is equal to 1. Okay? It only tells us that the explode or the coordinate of the explosion satisfy this standard equation of the hyperbola. And that is all for our fourth uh problem. Now, for your task, you have this performance task, no? The directions are form a group with 6 or 7 members, and you have to solve the problem that will be assigned to your group. Later, I will show you. And uh, I will also send you a soft copy of this slide or of this PDF. Now, the third task is to present your solution using MS PowerPoint or MS Word or LaTeX or in a Manila paper. Now note that the presentation should be video recorded, and you will submit it to me through Google Drive or Google Form, or uh, through sending me the link of the video that you have made. Okay, you can also upload it on Facebook or on YouTube. It's up to you. But after that, you will send the link to my email so that I can watch it also. No. Now, faces are not required in the video. If you want to show your face, okay, it's okay. But if you do not want to show your face, that is recommended because uh, faces naman are not important. Now, the criteria for grading are content accuracy, voice clarity, and accuracy of explanation, and visual aids. Now, just to give you the guidelines, every error in the solution is equivalent to a point deduction. So make sure that there is no error on your solution. For voice clarity, by the way, that is 50 points. For voice clarity, every vague word, pronounce, and error in the explanation is equivalent to a point deduction. And for visual aid, by the way, that is 25% or 25 points. For visual aids, every part that is not clearly written is equivalent to 5-point deduction. Tilted videos. This is very critical. Tilted videos will have no points in this criteria, meaning if your video is tilted, your highest possible grade is 75 points. And your presentation, or yes, your presentation should have no too small fonts because uh, it is not proper and I do not want to misread your work. Okay, presentation with too small fonts will have 10-point deduction. Okay, by the way, these are the problem. A Ferris wheel is elevated 1 meter above the ground or above ground. When a car reaches the highest point on the Ferris wheel, its altitude from ground level is 31 meters. How far away from the center horizontally is the car when it is at an altitude of 25 meters? Okay, problems on circles. That's the first one. Second one, a satellite dish in the shape of the paraboloid is 10 feet across and 4 feet deep at its vertex. How far is the receiver from the vertex if it is placed at the focus? Round off your answer to two decimal places. Actually, this is similar to what I presented a while ago. Parabola. Third one is for ellipse. The arc of a bridge is in the shape of a semi-ellipse with its major axis at the water level. Suppose the arc is 20 feet high in the middle and 120 feet across its major axis. How high above the water level is the arc? At a point 20 feet from the center horizontally. Okay? You have to round off to two decimal places your answer as well for this third. Okay, this is for ellipse, no? And for the for the hyperbola, actually it is also similar to the third problem that I presented. For the fourth one, hyperbola, two control towers are located at points -500 and 500 on a straight shore where the x-axis runs through. All distances are in meters. At the same moment, both towers sent a radio signal to a ship out at sea, each traveling at 300 meter per microseconds. The ship received the signal from Q 3 microseconds before the message from R. Now, this problem here or this task A here is required. It is required for you to answer. Find the equation of the curve containing the possible location of the ship. That is the first one. Well, the second one is a bonus question. If you want to have an additional point, I guess, no, you must answer this question. Find the coordinates. Find the coordinates rounded off to two decimal places of the ship if it is 200 meters from the shore. Meaning to say, y is equal to 200. So given the value of y and you have this equation, or after forming the equation in on part 1 or for letter A, you just need to substitute the value of y in the equation and then solve for the value of x. Okay? So that is all for the discussion, or that is all for our video lesson regarding the problems involving phonics sections. See you on our next video.